Hey everybody, I hope everyone is doing really well. I wanted to record a lecture here for you today. I'm sure, like I said, you're sick of doing the same problem set problems over and over again, so I wanted to try to move on to some new material, give this a shot. I'm gonna keep this quick. Unfortunately, I'm still having a hard time talking for more than like 10 minutes at a time. Really frustrating, unfortunately, but getting better and hoping to be back by Monday. And so I'll keep you posted on the plans for that. But I might be a little bit out of breath and taking some quick water breaks. So I'll try to keep this brief and then give you some of the period at the end to work on the problems that are giving you difficulty, and we'll go from there. All right. So before I get going with all this content related stuff, I just wanted to update you on the test and the logistics for that. So obviously it was supposed to be today. I'm gonna push it back till next Friday, and then we'll do some review next week on Thursday in particular. We're gonna take some time. We have to move on to Unit 3 next week, so we're not gonna spend too much time on this old material, but we will have Thursday to kind of just refresh you guys and ask questions and all that. But please do let me know if you have questions. I've been holding Zoom meetings after school, and then hopefully when I'm back next week, you can schedule a meeting in person and what have you. Okay, so test next Friday. It'll be on, you know what, let me make a little list here of all the topics so that you're squared away on that. I'll post this as well. So it's going to be everything we've covered in Unit 2, and there's a couple of small little tidbits we haven't really gotten to yet, but I'm just going to write them out for you. There's kind of 4 major topics. Number 1 is going to be graphing. Graphing consists of a couple of things, namely, let me make this a little bigger. Namely, so I might give you an equation, or a function, I should say. And your job is to turn it into a graph. So let's say I give you, I don't know, y equals 5x minus 6. Can you draw that? And then obviously vice versa as well. So if I give you a picture of a graph, can you tell me what that function looks like? I'll call this an equation. Okay, and we'll do a little subcategory here. All the sort of general functions that we've talked about. So that would be linear, quadratic, right? That's x squareds, that kind of stuff. Polynomial, which I'm going to circle back to in a second. Also can't spell. Apologies for that. Not an English teacher. Oh my goodness. There we go. Polynomial, and then absolute value, which we're going to talk about in just a few moments as well. Polynomial is the 1 over x and variations of that. I'm going to talk in more detail about that in a second. There we go. Okay, so graphing, let me think. Yeah, that should be, and then properties of graphs. So that consists of intercepts, x and y. That consists of, I wouldn't even say slopes because that's really just applicable to linear, so I don't think we need to worry about that too much. And then it'll be, I don't want to say vertices necessarily, but I'm gonna put it in there. You know what? I'll just more broadly call this domain and range Vertices is more sort of quadratic specific, so we'll get there in a couple of weeks. But domain and range and the intercepts is pretty much what you need to know as far as looking at a graph or an equation and figuring out the properties thereof. Okay, number 2 is going to be your translations. Okay, so that'll be, if I give you a parent function, or any function really, and I tell you, let's say, or you know what, I'll give you a function and I'll tell you it's translated however it's translated, x, y, z. Can you write the new function? So can you craft a new equation that satisfies however I told you it was translated? Sorry for the sorry that this is kind of drawn out and boring, but I want to make sure that all these topics are very clear and obvious for you guys. Okay, and then vice versa, right? If I give you a translation, so I give you a graph with a translated, or actually, if I give you a graph with translated function, can you write that function? And then also we'll say, if I give you a function and a second function. Now, obviously, a lot of this might be a little bit unclear without having examples, but I will post this and we'll talk through them. If I give you a function and a second function, can you tell me how it moved? So how was it translated? Okay, so I give you, let's say, I don't know, x squared. And then I give you, x minus 3 squared. How was that function translated? 3 units to the right, that kind of thing. All right. Number 3 is going to be your modeling, we'll call it. That's your typical, we've done this, we did this last unit, your sort of designing equations. The word problems, right? So your sort of cost profit functions. Mr. Thompson sells X loaves of bread. How many does he need to sell to make a profit? That kind of thing. Your sort of distance and space over time functions. So like your Dr. McKee drives his bike to work. How far is he from the mall? That kind of thing. And then your... Actually, I should say, I only really want to worry about linear equations for this unit, modeling-wise, right? This was sort of your bonus work for the first unit. It's going to be it's going to be part of the required curriculum. Sorry about that. For this unit. You're like barracuda swims to its prey kind of thing. How long does it take to get there if it starts, 2 miles from shore, blah, 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 blah. Okay. that's gonna, oh, and then let me, there's one more sort of small unit, or subunit, I should say, that I want to kind of delve into. This kind of stuff, your inequality stuff, I may or may not put something on there. That was definitely from last unit. I wanted to just give you guys an opportunity to get a little more practice. I probably won't put a question like this on the test, but make sure that common denominators, inequalities, that kind of stuff is comfortable. And good to go for the future. The last one, I guess this is kind of part of graphing, but I'll kind of create a fourth and separate category as piecewise functions, which we haven't talked about. It was in the problem set, but didn't get a chance to really talk about it in class or over Zoom or whatever. So this is this is really a part of graphing, but I'll consider this a new thing, and I'll send this to you guys. So I'll upload this to Schoology. I don't have to do it now, but let's call this Unit 2 Test Curriculum. Okay, so we'll worry about that later. But what I want to do now, and again, I apologize for how long this is taking and my slow pace, but I want to talk through some of the stuff that was in these problem sets that you didn't get a chance to really learn from me. You kind of had to work them out yourselves due to me not being there. Side note, actually, before I continue, don't forget your problem sets were due last night. So if they're not in yet, definitely get those to me as soon as you can. They're late, so please make sure they are uploaded, all 3 parts. And then I'm going to give you a homework assignment due probably like Wednesday for test review, okay? But let me go through, grab a sip of water, and then talk about piecewise functions, okay? So if I give you this is a piecewise function, and what I mean by that is it's a function that basically has a different function for each, we call these intervals. So we define at x equals such and such, right, over that interval. So let's say this one, when x is less than 0, this is our function. When x is between 0 and 3, this is our function. So it's basically a function made up of multiple functions over different intervals as in x values, okay? And it looks something, this is just one example of a generic piecewise function, right? But it's actually coincidentally similar to what this is going to look like, but it's a completely different shape, right? A completely different line for each interval, right? Each chunk. Okay, so for this one, let's open up a new tab. Let me do this. And I'm just going to kind of draw a picture, or Desmos is going to draw a picture for me more accurately, of what this function is going to look like. Okay, so we have 3 separate little chunks. Over the interval of x is less than 0, f of x, or y, is going to equal negative x. Okay, so in general, right, if I say f of x, this is a really good graphing program that we're going to use later in the year that you can always use to help yourself out if you want to sort of visualize what a function looks like. F of x equals negative x in general, right, if that's our only function, is going to look like this, right? It's our regular sort of very, very generic f of x equals x looks like that, right? Because for every time x increases by 1, y is obviously going to increase by 1. If you plug in, let's say, 5 for x, y is going to be 5. That sort of thing. That should be pretty self-explanatory, but if we have y equals negative x, it's just going to flip. Now we'll talk about how and the terminology for that. It's this is a reflection of the first graph, right? That just regular positive x. But you can sort of intuitively, hopefully, understand, right? If you plug in, let's say 5 this time for x, y is obviously going to be negative 5, okay? So you plug in 5, which is right here, for x, so your x value, and then y is negative 5 rather than being up here at positive 5. And I apologize for having to just follow my words and my mouse. Obviously, it's not the most efficient or effective, I should say, way of conveying this material, but bear with me on that. And then if you plug in negative 5, instead of getting negative 5, you'll get positive 5, so you'll be up here, right, at x equals negative 5, y equals positive 5. But that is just one chunk of this function, only when x is less than 0, okay? So this is our function until, or I should say, starting at negative infinity, so all the way, this is very unclear, but in that direction, if that makes sense, all the way until you get to x equals 0. So I'm going to enter that into Desmos and say x less than 0, okay? So now what happened is our function got cut off at x equals 0. Only showing this negative x function for the x values between negative infinity and 0, okay? Now, we have another chunk of this function, x squared, okay, when x is between 0 and 3, including those two values, okay? So f of x equals x squared should look familiar to you. It should look like that, a parabola, right? But again, this is only what our graph looks like at x, or when x is between 0 and 3. Okay, so keep in mind this right here, what I've just created is not a function, right? It doesn't pass. Remember we talked about the vertical line test a little bit, right? There's more than one y value for every x value between 0 and infinity, right? Or negative infinity, I should say, right? So you can't have an overlapping interval, right? You can't have a function of negative x overlapping with a function of, let's say, x squared, okay? So our interval for this, I put between, how do I do this? Oh, nice. 0 and 3. So what it just did, right, if I get rid of this, remember what this looks like, is this parabola that goes on forever, right? Goes on forever in the x direction, both sides, and then starts at 0 and goes on forever for y. But what I've created instead is just that function, over the interval 0 to 3. Including those two values. So let me zoom in a little bit, and basically what it did, not basically, exactly what it did, is it graphed this equation, x squared, only when x is between 0 and 3. Okay, so when x equals 3, y equals 9, right? Which makes sense because x squared, or excuse me, 3 squared is 9. And it cuts it off right there because that's the end of our interval, okay? Now, our third chunk is y equals, or f of x equals 5, when x is greater than 3. So the function f of x equals 5 is just a straight line at y equals 5, right? Because no matter where we are on x, y is always going to equal 5. So it's a straight line across. But again, it's only over the interval x is greater than 3. Okay, so it looks like that. It's going to start at x equals 3, and then go on forever. So this is the graph of that function. 3 different shapes, 3 different lines for the 3 intervals, right? 1 for each. So what you want to do when you're graphing a piecewise function is just look at each interval separately and then graph that function only over that interval, okay? So this function, if our interval was everything, right, it would keep going in this direction, but it doesn't because we defined it only at x is less than 0, okay? Same thing for these two. Hopefully that makes sense. We're going to do some more practice with that, but I just walked you through how to graph this first question of part 3, and then I asked you for the domain and range, okay? So nothing changes, right? Same idea when we have a domain and range in the, with the functions that we've been working with over the interval of everything, right? We have our domain representing everything that x can be, and our range representing everything that y can be, okay? So over this function, x can be anything, right? It's going to go on forever in this direction. It's going to go on forever in this direction. So x can be any number, negative infinity to infinity. Now, that's not always going to be the case, right? If we, let's say, deleted, okay, this function, and we have this empty space here, it's going to go on forever this way, it's going to go on forever this way, but this space from 0 to 3 is undefined. There's no function there. Okay, so our domain would be negative infinity to 0, and then we have to use that union sign, remember the U, to say negative infinity to 0 plus 3 to infinity, with the interval 0 to 3 not included. Okay? And we would use hard brackets because those exact values, right? 3 and, ooh, that's interesting, actually. We wouldn't use a hard bracket, we would use a soft bracket, because I forgot that it was x is greater than 3, not x is greater than equal to 3. I know that can get confusing, so we'll do more practice with that. But if we deleted that second function, then we would have empty space, which means it's not included, right, in our domain. But if I put that back, it is. So now everything is included. So it's negative infinity to infinity. And then for the range, it's everything that y can be, right? So there's nothing below 0 that is included, okay? And it's going to go on forever in the positive direction, oops, because this line right here is going to go on forever. North, right, up. If this line wasn't here, let's say, our domain would be what? It would be 0 all the way up to 9, because that's the highest y value that we have. Okay? But it is there. So we have, I don't know why it keeps changing the colors, but 0 to infinity. Okay? That's the only question on here that we haven't really covered in class. Everything else was discussed in class, maybe not in as much detail as I would like, because I know a lot of you still have questions, but everything else should at least look familiar. So if you do have questions, again, I should have your problem sets already, but if I don't, please get them to me. If you have questions, please let me know. If we look at something like this, right, this is one of those modeling problems. I'm just going to run you through a couple really important things to keep in mind. Units, okay? I intentionally gave you different units, right? I told you that every foot it rains, the puddle will increase by 1 gallon, but your x value, right, you're going to get an equation that looks like, let me write this out, that looks like y equals, or f of x equals mx plus b, right? Because as we know, it's going to be a linear equation. Why? Because we have a consistent slope of 1 foot every gallon, or 1 gallon every foot. But y is going to be, what did I say? F of x is the amount of gallons, and x is the number of inches it's rained. right? So f of x is gallons, x is number of inches it's rained, okay? But I gave you the amount the gallons increase per foot, not inches. So be careful. You have to, you don't just want to, you have to convert your units to whatever x represents, okay? So really what you're saying here is for every gallon that the puddle increases by, it's rained how many inches? 12 inches, right? Because there are 12 inches in a foot. So we're going to create an equation that says every time y goes up by 1, meaning the gallons, x goes up by 12, okay? So what's our slope? If y goes, how am I going to do this? I'm just going to write it out. Up by 1, x goes up by 12, which means that when x goes up by 1, y goes up by how many? This is very similar to the Missisponda gas tank problem. Y goes up by 1/12, right? If x goes up by 1, y goes up by 1/12, right? Because we divided each by 12. Does that make sense? Hopefully a little bit. Do more practice with it. So we know our slope is going to be, I hope this is big enough and you can all see this. Kind of forgot about that. My bad. F of x equals 1/12 times x. That's our slope. And then we have to find our y-intercept, our b. How are we going to find that? Well, our y-intercept is when x equals 0, right? That should sound familiar. And I told you that when x equals 0, meaning it hasn't rained at all, it currently consists of 10 gallons. Okay, so that's, if no rain has added, right, any volume to our puddle, it's going to have 10 gallons because that's where it starts. So our intercept is going to be 10. That's our equation. F of x equals 1/12 x plus 10. And then you can use that to figure out how many inches it'll rain. Hopefully that makes some sense. This question, we're not going to go through it, but there are 4 functions here with the same parent function, which is this red one, x squared. That should look familiar. This one is translated up, so I want you to figure out what that equation is. Translate it to the right, I want you to figure out what that equation is. And this one is just flipped, right? Reflected, which we haven't really talked about yet, over the x-axis, okay? So try to figure out what is different about this equation, this green one, from this red one, okay? Now, last thing, absolute values, okay? I think the easiest way to do this is through graphing. So let's do this on here, okay? Let's go back to our our f of x equals x, okay? This should obviously look familiar. It's just a straight line that goes up 1 for y every time x goes up by 1, okay? Now, what's going to happen if I create an absolute value function for this instead? Well, if we plug in, let's say -5 for x, what are we going to get for y? We're going to get -5, okay? If we have the absolute value of x, what are we going to get? We are going to get +5, right? So the way that it changes the graph is it creates this V shape, right? Because for every time you plug in a negative number for x, so anything to the left of the y-axis, instead of being down here at whatever that same value is, right? If you plug in -15, you'd get -15, but instead now it's an absolute value, which means if you plug in -15 for x, y is going to be +15 up here. So if I take out the absolute values, it's a straight line like that. If I add them, it's this V shape, right? Because again, every negative value for x, y is going to be that same number, just positive. Okay. Now that's pretty much all absolute value functions are. The only thing beyond that you'll need to understand for this unit is translations, right? We've done a lot of work with translations. That still applies for absolute values. So same kind of thing, right? If I add something outside of the function, right, outside of the absolute value, it's going to translate it up and down. So if I say our absolute value of x, so remember what this parent function looks like. It looks like this v starting at the origin. If I add a plus 3, it's just going to translate it up 3 units. Minus 3, down 3 units. Okay? And then if I do something within the function, plus 3, it's going to translate it 3 to the left. Like that. Makes sense? Minus 3, 3 to the right. So same thing applies for this parent function of f of x equals the absolute value of x. But the only thing to keep in mind for absolute values, again, is you're never going to have any negative numbers for y. Now, that's only true, right, if it's if that's all there is to it. Like I said, if you do minus 3 here, it's going to go down by 3, right? So if you plug in 0 for x, you're going to get 0 minus 3 for y, which is negative 3. Okay? So let's say I asked you for the domain for this function. It would be negative infinity. It's going to go on forever, positive infinity. And the range would be negative 3 down here. It's the lowest y value we have, all the way up to positive infinity. Cool. Hopefully that makes sense. I think we'll cut it there. And I'll give you, I don't know how much time I've been yapping for, so apologies and appreciate your patience. But if there is time left over, which I assume there is, in the period, why don't you head over to the problem set problems that maybe gave you some trouble, work in your groups, and try to figure them out with the info that I just gave you. All right, cool. Thank you guys very much. Again, apologies for all this. Hopefully back by Monday. I got to go in for some more testing and figure out what's going on. But yeah, hopefully back by Monday, and definitely get in touch with me if you want to talk about certain problems, or just in general if you're feeling like you need some extra practice for the test. Definitely let me know, and I'm also going to post that homework so you can do some review there as well. Yeah, thank you guys. Let me know if you have any questions at all, material-wise or otherwise, and really miss you all so much. That's like been easily the most frustrating thing. I'm just like, when can I get back there and see everybody? So I'll get there, and I'll hopefully see you soon. All right, thank you guys.